This is Mr. Beck Does Your Homework, AP Physics, Homework 8.4, questions number 3 and 4. A particular engine has a power output of 4 kilowatts. Now wait a second, that's 4,000 watts, but this is a power output. Normally I'm interested in the work output, so I'm going to have to figure out what to do with that in a little bit. And an efficiency of 30%, so that's my efficiency is going to be 30%. If the engine expels 6,897 joules of thermal energy in each cycle, that's Q, and that's Q out of the cycle. Find the heat absorbed in each cycle. So what I've got is I've got a Q in, or Q hot, and that goes into the cycle that's going around, okay? And then I'm going to expel some heat out of that, and that's going to be my Q out. And I'm also going to get some work out of this cycle. So this is my work out. And what this tells me is that I'm going to get some energy in, I'm going to get some work out, and it says that 30% is going this way. What that means is that if 30% of the total is going this way, then I must be getting 70% this way, and whatever your numbers are. So this is an efficiency of 30%. That tells me 30% of the heat absorbed from the hot. This could also be Q hot. And this could be Q cold if you're thinking of it that way, because I've got my hot reservoir and my cold reservoir. 30% of what goes into the cycle is coming out as good work. The rest of it is going out as bad work. Now this says that 6,897 joules is expelled in each cycle. So I know that this is going to be, that my Q out is going to be 6,897. I also know that that represents 70% of the total. So I want Q in. So I could just do this as a ratio. So I can have Q in is to 100% as 6,897 is to 70%, is to 70%. So I could say, yeah, to 100%. So if I take 6897 times 100 divided by 70, I will get my Q in. So this should be a bigger number so that 70% of it is coming this way and 30% of it is going that way. So that's a way to get the amount of energy I put into the cycle, and that's this one, answer in number of joules. Now it gets tricky. It says find the time for each cycle. Well, now I could say 30% of it is going to be my work that I get out every cycle. So if I get 6897 as waste, I'm going to get the rest, I'm going to get 30% of the total of the Q in as my work, okay? So of the Q in, I know that with an efficiency of 30%, I know that 30% of Q in is going to equal work out. And I know that 70% in my case of Q in is going to equal Q out. So that's my 100% of Q in is taken into account of how much work and how much Q. So if I know Q in, I can figure out my work out, the amount of joules that I have for work out. So I can calculate and get some number of joules. And this is joules per cycle. So the work out is how many joules I get per cycle. Now I also know, since it's 4,000 watts, 4 kilowatts, I know that I have 4 kilowatts tells me that I've got 4,000 watts. Well, a watt I know is a joule per second, so that's going to be 4,000 joules per second. So I have joules per second and I have joules per cycle. What I want is cycles per second. So if I take joules per second and I divide it by joules per cycle, that's the same thing as multiplying by the inverse. So that's going to be joules per second times cycles per joule. So if I flip this one and multiply, I've got joules per second times cycles per joule. Shift that up just a little bit. Now you can see the joules goes away, and this will give me cycles per second. And that's what I'm interested in. So I have to take my joules per second, which is my watts, and divide it by my joules per cycle, and that will give me the right units. That'll give me cycles per second. That is the time for each cycle. Oh, I just did that backwards. What I really want is seconds per cycle, don't I? So if I do this the other way, so flip this all. So let's get rid of that. If I want seconds per cycle, now I've got joules per cycle and joules per second. So if I joules per cycle divided by joules per second, then it's going to equal joules per cycle times seconds per joule. Joules cancel out, and I'm left with seconds per cycle. Trust me, rewind that, listen to it, and you will see exactly what we got here. So we've got joules per cycle, this one, divided by the joules per second, and that'll leave me with seconds per cycle.